On the physical layer, we are going to have data link layer, then network layer, transport layer, session layer, presentation layer, application layer. So like this, we are having what, 7 layers. Okay. So each layer we have seen the functionality also. Okay. Now coming to this error control and flow control. So these are the functionalities at the data link layer. Okay. So physical layer, we have seen about the signals, right? So physical layer is going to deal with the raw data. So that is what signals. In the first unit itself, we have covered all those signals and wired transmission media, wireless transmission media, which transmission media we are using. Okay, analog signals, digital signals, okay, encoding techniques. So we have seen all these in the first unit, right? Then coming to the second unit, we have started with what? The data link layer. So what operations we are performing. Okay, so we have gone through the error control. Okay, so that is one operation. Now coming to the other operation, so that is also handled by the data link layer, is flow control. Okay, the name itself, it is saying what? Flow. So flow means data flow from the transmitter to the receiver, right? So we are from the sender to the receiver, the data is being transmitted. So when it is transmitting, so the flow of data, so this flow need to be controlled. Why we need to control the flow? Like for example, in the reality, if you are considering, okay, so on the roads, okay, so the data, like what, the traffic is going on. So if there is no control on the traffic, right, if there is no control on the traffic, then what happens? Anybody can move like anyway. Okay, so there may be chances of what? Lots of accidents. Okay, so no proper path. Okay, they will follow, they don't follow the rules and regulations, they are going ahead. Okay, so because of that, there will not be having what are the proper transmission. Okay, so road transmission, so that should also be proper. So if we are not controlling the traffic, so there will not be proper transmission. If there is no proper transmissions, more chances of what? The accidents. So for the accident means what? Loss of human. Okay, so we are going to lose our human beings itself, right? So the same way, if we are going for the data transmission, so the data also is the traffic on the network. Okay, so this traffic need to be controlled. Okay, from sender to the receiver, so the traffic need to be controlled. So this traffic, we are going to control the flow of traffic. Okay, just like signals we are having in the roads, right? The same way here, we need to put what? Some signals, some indications to control the flow of data. So where we need to have, so why we need to go for this flow control? So like for example, the sender and the receiver. If the sender is very fast in transmission and receiver is very slow in reception. Okay, that means what? The sender is transmitting high amount of data, number of packets it is transmitting, but the receiver is unable to receive all the packets at the same time. Okay, so when it is not able to receive, what happens? Lots of data will be lost. Okay, that means what? The loss of frames can occur at the receiver. Okay, the loss of frames, whatever the data frames we are transmitting from the sender, so that has to be received by the receiver. But if those are, the sender is very fast and the receiver is very slow, then there is a chance of what? Loss of frames at the receiver. Okay, so this problem we have to overcome. So how do we overcome? So that is by using flow control mechanisms. This is also will be provided at the what? Data link layer. Okay, if I am going for the OSR reference layer, it is at the data link layer. If I go for TCP/IP layer, so data link layer and physical layer both together we are having. So there the the physical layer itself will handle this error control and flow control. Now coming to OSI reference model, these are divided, right? So coming to the flow control, so this will be handled at the data link layer. Okay, so here to control the flow, okay, so we are having the two common methods. One is feedback based and the second one is rate based. Okay, so feedback based means some feedback need to be collected from the receiver and will be given to the sender. Okay, so the sender, what it will do, it will take the feedback from the receiver whether you are receiving all my data or not, properly or not, so that it is going to receive the feedback. So according to the feedback it will control. So if the receiver is saying what I am unable to receive, okay, then the sender, what it will do, it will stop the transmission and retransmit any packets which it has lost, so it will retransmit. Okay, so for this the feedback based flow control it can use. Okay, so what kind of feedback it can take from the receiver? Okay, that means it is asking the receiver that whether you are received or not. So how it will ask and how it will indicate that the receiver has received or not? That is by using the acknowledgements. Okay, so when the sender is transmitting, the receiver has to give the acknowledgement that I have received. If it is not receiving, it will not give the acknowledgement. So based upon that, the sender can understand, okay, it has not received this particular packet. So what I need to do, I need to control myself and limit the number of packet transmission. So that is how the acknowledgements can be used. Or this sender will ask, what is your speed of reception? Okay, my speed of transmission is this one, what is your speed of reception? So the receiver has to tell, so my speed of reception is like 100 packets per second. Then the sender, what it will do, it will restrict itself by reducing the number of packets, like 100 packets only it will transmit. So in that way also the flow can be controlled. So feedback based means what? The sender is going to take some information, some feedback from the receiver. That is, it can be in the form of the acknowledgements, or it can be the uh, the, the information related to the speed of receiver. Okay, so that is one kind. Or else the second one is what? Rate based flow control. So here in the feedback based flow control, the receiver is involved, but coming to the rate based flow control, directly the receiver will not be involved, it is not going to give any feedback, but some internal mechanism will be implemented. Okay, so some kind of program will be developed to identify what is the transmission rate. Okay, so that is, one packet will be transmitted and it will get back, so like some hello packet will be transmitted, and at the receiver, at what time it is receiving, it will identify. So based upon that, so it is going to identify the rate, how much of the packets it can receive. So internal mechanism will be implemented. Okay, based upon what? Some sample packets, not the original data, but some sample packets will be transmitted, and it is transmitting and return back how much of time it is taking. So based upon the time duration, it will identify the rate, and based upon the rate of rate, it can reduce the transmission. So that is what? Rate based flow control. So there are two types: feedback based flow control or rate based flow control. Feedback based, the receiver is going to give the feedback, and rate based, the sender is going to have an internal mechanism to identify the speed. Okay, transmission speed. So that is what the rate based and feedback based. Now the data link layer will use what? Feedback based flow control. So generally what happens, any OSI layer implementation, the data link layer will go for feedback based, because rate based means a separate programming should be implemented. So instead of that, the simple one is feedback based flow control will be used. Okay, so this is the important note Okay, so the data link layer will use feedback based flow control. Now coming to the protocols. Okay, so protocols are nothing but what kind of, to implement these, to implement the feedback based flow control. So what kind of algorithms we are going to use, what kind of rules and regulations we can implement. So in that one we have two categories of protocols. Protocols are nothing but what? Set of rules. To implement this concept, what are the rules to be done? Okay, what are the rules to be followed? So for this we have two types of protocols suggested. Okay, one is elementary data link layer protocols and the second one is sliding window protocols. First one is elementary data link layer protocols and the second one is sliding window protocols. So the elementary data link layer protocols, these are also called simplex protocols. Okay, simplex protocols. Why? Because they are going to implement in the simplex transmission. Okay, simplex transmission means what? The data will be unidirectional. Okay, only from the sender to the receiver the data will be transmitted. Okay, receiver is not going to send back the data. Okay, the data is being transmitted from the sender to the receiver only in unidirection. Okay, unidirection. We have already seen about these terms: simplex, half duplex and duplex or full duplex, right? So coming to elementary data link layer protocols, these are implemented in simplex transmission, that is unidirectional transmission. Only the data will flow in one direction. Okay, the second one is sliding window protocol. So sliding window protocols are what? In the duplex transmission. So these will be implemented in the duplex transmission. That is, the data will be flowing in bidirectional. That is, from the sender to the receiver the data will flow, and from the receiver to the sender back the data will flow. Okay, so that is elementary data link protocols are unidirectional, sliding window protocols are bidirectional. This point you have to remember. Okay, then coming to elementary data link protocol. So in the elementary data link layer protocols, we have three types of protocols. Okay, actually the protocols are of two categories. One is simplex, that is elementary, and the second one is implemented for duplex transmission. Okay, so that is sliding window protocols. In simplex transmission, in elementary data link layer protocols, again we have three types of protocols. Okay, do understand this point. Okay, so there are two methods. One is feedback based and the second method is rate based for flow control. Okay, so data link layer will go for what? Feedback based flow control. And coming to the protocols in the data link layer. So to implement this feedback based flow control, so what are the rules to be followed? Some set of rules are framed. Okay, so those rules are nothing but the protocols. There are two types of protocols. One is elementary data link layer protocols. Second one is sliding window protocols. So elementary data link layer protocols are unidirectional. Sliding window protocols are bidirectional. Okay, and coming to elementary data link layer protocols, again we have what? Three categories. One is unrestricted simplex protocol, simplex stop and wait protocol, simplex protocol for noisy channel. Okay, so unrestricted, simplex protocol for noisy channel. Clear? So all these three are what? Simplex protocols itself. Simplex and simplex. Unrestricted, second one is what? Stop and wait, and the third one is what? Protocol for noisy channel. So these are what? Three basic elementary data link layer protocols. And when you are going for these data link layer protocols, the generalized frame format to implement the flow control, the generalized frame format is this one. Okay, so you can see I'm writing in the two ways. So one is kind, sequence and acknowledgement, information and CRC. So that is nothing but the header, payload and trailer. So header will include what? Kind, sequence number, acknowledgement. So these three will be in the header part. Then payload is nothing but the data part, and CRC, that is what? What is CRC? For error control. Okay, trailer part. So in the data link layer, the generalized format is header, payload and trailer. In the header, we can include kind, sequence number, acknowledgement number. Then payload is nothing but the data, what is the actual data to be transmitted, and trailer, that is nothing but the CRC for error detection. Okay. Now coming to these fields, what is this kind, sequence number and acknowledgement are? So kind is going to indicate what kind of uh, frame it is, what kind of data frame it is. So whether it is data frame or the acknowledgement frame, because the sender is transmitting the data. Okay, the receiver will give the acknowledgement, right? So what kind of frame it is? So whether it is data frame or the acknowledgement frame. So to identify the frame itself, we are going to use the kind. So as we have two types, one is data frame and one is acknowledgement frame. So to identify the difference between these two, we can use a single bit. Okay, so that can be either 1 or 0. If I am taking 1, it can be what? Data frame, and if I take 0, it can be what? Acknowledgement frame. So in that way, we can use this kind field. Then coming to the sequence number. So for each frame, it is going to maintain the sequence number. Okay, like 1, 2, 3. Why we are going to use the sequence number? The same frame, if it is received, we can understand. So the receiver has to receive 2, and next it is receiving 3. It has to receive next 3. But what happens again? The second frame is transmitted. That means what? Duplicate frame is received. So to identify whether it is the new frame or duplicate frame, we can go for what? Sequence number. Okay. Then coming to ACK. ACK is what? Acknowledgement. Okay. So if it is the acknowledgement frame, so for which frame we are going to transmit the acknowledgement. So that is what? Acknowledgement number we are going to include. Okay. So kind, sequence number, acknowledgement. So these all three may not be used in all these protocols. Okay. So some may be used, some may not be used. So which one will be used, which one may not be used, that depends on the protocol category. Okay. So here, so that is what I am indicating here. Depends on the protocol type. All the fields of headers and trailer may or may not be included in the frame. Clear? So may or may not be included in the frame. So now coming to the first one. In the elementary data link layer protocols, so the first one is unrestricted simplex protocol. Okay, so this is the name itself, it is saying it is simplex protocol. That is what? The data is unidirectional. It is simplex protocol, the data is unidirectional. Okay, and only, that is what, only the sender can transmit the data frames. Clear? So that is the first feature. Then coming to the unrestricted. Okay, unrestricted. Unrestricted means that is, it is not going to provide any error control or flow control. Okay, that means no error control, no flow control. That means if I am taking this particular frame, it is going to have only the information field, no error control, no CRC or no kind, sequence number and acknowledgement, nothing. Okay, so no error control, no flow control. So it will be having only information field. Okay, and it is providing only framing, that is from where to where the data frame is starting and where it is ending. So we have already seen. So to to identify the boundaries, start bit or stop bit, or starting flag or ending flag. So we need to indicate these. Okay, so only that will be defined, only the boundaries will be defined, but no error control, no flow control. So that is unrestricted simplex protocol. That is, we are not at all providing any error control, flow control. Okay, so if it is error control, flow control is not provided, so obviously it is having what disadvantages. So this is what the basic one. Okay, after that the second one is simplex stop and wait protocol. Okay, simplex stop and wait protocol. So stop and wait protocol means what? Stop and wait. So it has to wait for the acknowledgement. Okay, so here what are the features it is going to provide? That is, it is providing simplex transmission. Okay, that is what unidirectional. Okay, channel is assumed to be error free. That means it is not providing the error control. Okay, it is not providing the error control, but it is going to provide some sort of flow control. Okay, that is, the receiver gives the feedback to the sender to prevent the sender from flooding. That means the sender should not transmit the data as its speed. Okay, it has to restrict. Okay, it is going to provide the flow control. So how it is going to provide the flow control? It uses the acknowledgements as the feedback. That is, the receiver has to give the acknowledgement. So sender will transmit one frame, and once it is transmitting the frame, it will stop sending from the next frame, and it will wait for the acknowledgement from the receiver. Okay, the receiver, what it does, once it has received the frame, it will give the acknowledgement. When the acknowledgement is received by the sender will transmit the next frame. Okay, it is like what we are transmitting. The receiver has to give the acknowledgement that I have received. Once it has given the acknowledgement, the sender will give the next frame. So like this. So as what it is doing, it is sending one frame and waiting for the acknowledgement. So that is why it is said to be what? Stop and wait. Okay. Once it is transmitting one frame, it will stop and wait for the next acknowledgement. So once the acknowledgement is received, it will transmit the next frame. Okay. So like this, it is going to use this simplex stop and wait protocol. So as it is using the acknowledgements, it is waiting for the acknowledgement, and it is going to transmit only when the receiver has given the acknowledgement. So because of this, the flow control is provided, but no error control. Okay, so the third protocol is simplex protocol for noisy channel. So as it is assuming it is noisy channel, that means what? There is a chance of error, so it will provide the error control. Okay, the simplex protocol for noisy channel will provide the flow control as well as the error control. Okay, so it is unidirectional transmission. So you may be thinking that the receiver is also sending some information like in the form of acknowledgement, right? But when it is transmitting, the data will be flowing only from the sender to the receiver. The receiver is not giving the data back to the sender. It is giving only the acknowledgement. Okay, clear? Acknowledgement is not considered as data. So that's why it is simplex only. So unidirectional transmission, the channel is assumed to be noisy, so it is providing the error control as well as flow control. Clear? So error control as well as flow control. So for flow control, it is using the acknowledgement. Okay, that means what? It will wait for the acknowledgement, and for the error control, it is going to use CRC. So what is CRC? Cyclic redundancy check. How we are calculating? By using the polynomial. Yes or not? Polynomial code, how we are going to generate. So it both the sender and the receiver will have one common key. So that is called generator polynomial. And this generator polynomial, how many number of bits are there? So we are adding those many number of bits to the transmitter. The message at the end. Okay, and we are going to divide the message with the additional bits by the key, and whatever the reminder we are getting, that we are taking as CRC message. Along with the CRC we are transmitting. Okay, so when we are transmitting at the receiver, what it does, it will again perform the division, the received message divided by the generator polynomial, that is the key. Okay, then it has to get the answer, the reminder as zeros. If it is getting non-zero, means there is error. If it is getting zero, means there is no error. So based upon that, it can detect the error. So that is what the error control it is going to provide. Okay, so that is what flow control, error control. Okay, so that is about the simplex protocol for noisy channel. Okay, and when you're going for this acknowledgement, okay, so there is any error in the acknowledgement, so what happens, the acknowledgement will not be sent back. Yes or no? If there is any error in the received frame, the acknowledgement will not be sent back. The sender will use some timer. So how much of time it has to wait? It will wait for some amount of time for the acknowledgement. If the acknowledgement is not received, so it will be transmitted back. Okay, but there is a problem with this acknowledgements. Okay, so that is, if I am transmitting one frame, okay, that may be delayed. Okay, because of delayed, so the sender will not receive the acknowledgement in time. Okay, and the duplicate frame will be transmitted. So at the receiver there is a chance of what, reception of duplicate frames. So to avoid the duplicate frames, the sequence number will be used. Okay, the sequence number will be used. But how many number of bits we have to allocate for the sequence number? Okay, coming to this simplex protocol, for noisy channel, it will use a single bit sequence number. Okay, a single bit sequence number. That is, the bit can be what, either 0 or 1. So it is going to give the numbering for the frames as 0, 1, then next again, next frame 0, again next frame 1. So that means what, alternate zeros and ones will be allocated for the frame numbers. So these are what, the sequence numbers of the frame. So first one is what, 0. Next one is what, 1. Next one is 0. Next one is 1. Next one is 0. So like that it's going to give. Now the sender, for example, it wants to transmit this. Okay, these frames. Okay, how these are numbered? 1 0 1 0 1 0 1. So like this it is numbering. Okay, so first it will transmit. Last 5 minutes are there, please post your attendance. Meanwhile we'll continue the class, right? So how it will transmit, one by one it will be transmitting. So it will wait for the receiver. What it does, when it is receiving the frame, so it is receiving the frame number, for example 1. Okay, the next expected will be what, 0. Next, after receiving 0, next expected will be what, 1. After this, next expected will be 0. So like this, alternate zeros and ones it is going to expect. Now the sender, what it does, for example, it is sending the first frame. Okay, it is sending the first frame to the receiver. So receiver is receiving frame number 1. So what it is doing, it is expecting for the next expected is 0, and acknowledgement is sent back. Okay, if the acknowledgement is lost, okay, if the acknowledgement is lost, so what happens, if the acknowledgement is lost, means the sender is not receiving this acknowledgement. Okay, so when the acknowledgement is not received, the sender, what it does, it will retransmit the same frame. But what the receiver is expecting, the receiver is actually expecting 0, but what it is receiving, it is receiving 1. That is, actual expectation is 0, but receiving is 1. So because of that, what it does, it can identify that it is receiving a duplicate frame, so it is simply discarding. Okay, so that is how the sequence numbers can be used. And until and unless the sender is not receiving the acknowledgement, it will not retransmit the next frame. It will wait for the acknowledgement. Once the acknowledgement is received, then only it will transmit the next frame. Okay, so here in the acknowledgements there are two other ways. Okay, using the acknowledgement. One is positive and negative acknowledgement. Okay, so positive acknowledgement indicates, that is positive
Thank you
acknowledgement.
so
Yes, positive acknowledgement with retransmission, or it is also called automatic repeat request. Okay, so positive acknowledgement and negative acknowledgement. Positive acknowledgement in the sense what it is received. Okay, it has received. And negative acknowledgement means it may have lost the frame, or the frame whatever it has received may have the error. Okay, so that is said to be what? Positive acknowledgement and negative acknowledgement. Okay, so positive acknowledgement with retransmission indicates whenever it is transmitting, okay, if there is no error, it will give the positive acknowledgement. And if there is no error, so yeah, if it has lost the acknowledgement, automatically repeat for the request. Okay, so that is what it is, requesting for the same frame to transmit back. Okay, so that is said to be what? Automatic repeat request. So what the header fields will include sequence number and the acknowledgement, and trailer we are going to include the CRC. Okay, so that is about the third one, simplex protocol for noisy channel. So there are three protocols, elementary protocols: simplex protocol, unrestricted simplex protocol, simplex stop and wait protocol, and simplex protocol for noisy channel. Okay, so these are the three basic protocols. Sliding window protocols we'll see in the next class. Any doubt? If you have no doubt, please give your attendance and you can exit the class.